recording. Click here to begin. All right, so we're going to look specifically at motion graphs and recognizing patterns in shapes. The first thing that we're going to look at is zero acceleration. Okay, a zero acceleration graph, acceleration versus time. A zero acceleration graph looks like that. Okay. Now, before we even start talking about the velocity graph, acceleration equals 0 tells me that I have no change in my velocity. Okay. The acceleration is the change in velocity over the change in time, and acceleration is 0, then velocity, or the change in velocity, is equal to 0. That means I have a constant velocity. So let's look at velocity versus time and see what constant velocity means. And then look at some general rules for interpretation that we can take away with this. So we have velocity versus time. The first thing I know is that acceleration is the slope of velocity versus time. Well, if that's the case and acceleration equals 0, then my slope for velocity versus time equals 0. If the slope of my line is 0, that means I have a horizontal line, which means velocity versus time could look like this, where I have a constant positive velocity. That's one possibility. So we're going to, or I could have constant negative velocity, or I could have 0 velocity. So we're going to look at this one first. We'll call that 1, we'll call that 2, and we'll call that 3. Those are the possibilities that I could have for velocity. So what we're going to do is look at how those look on position versus time. So if we're going to look at 1 first, positive velocity equals, well, that's going to throw things off, isn't it? Positive velocity equals positive slope. So, for 1 being a positive velocity, the displacement versus time for that, all it has to show is a positive slope. For 2, zero velocity equals 0 slope. Well, 0 slope on position versus time, and I'll make that color different because they're going to cross. Doesn't matter where it is, I don't have any information about that, is just a horizontal line. And then the last one, 3, negative velocity equals a negative. So, negative slope would be anything like this. All of these slopes are still constant because this velocity is constant. They're not changing slopes, but positive velocity gave me a positive slope. 0 velocity gave me a 0 slope. Negative velocity gave me a negative slope. These are all the things that we can get with 0 acceleration. We're going to make things more complicated and look at positive acceleration. When we have positive acceleration, our graph of acceleration versus time is, should should be a horizontal line, is a horizontal line moving out this way. So we're going to have two possibilities for velocity versus time with this. First off, what this means is that velocity changes in positive direction. And if we look at velocity versus time, I'm going to do two separate ones. I think that's going to be easier to see everything. Velocity versus time over here, and velocity versus time over here. Looking at each of these, I can say that positive acceleration for velocity versus time means that I have positive slope. Now, these two things mean two very different things, okay? But a positive slope on velocity versus time could look like this, and a positive slope on velocity versus time could look like this. Each of these are positive slopes. They are sloping upward. That's showing my velocity changing in the positive direction. So, looking at this one, velocity starts at 0 and becomes big and positive. That's what we see here. My velocity starts at 0 and it becomes big and positive. And looking at this, the area of this graph is all positive. So what I can say is that we have a positive displacement from this graph. So my velocity starts at 0 and becomes more positive. So let's look at what that's going to look like for displacement versus time. Now, I know that the velocity here is the slope of my line. So I'm moving forward, which means I'm going to start here and end up forward in the positive direction. Now, my velocity starts at 0. Velocity is my slope. That means my slope starts at 0 and my velocity becomes more positive, so my slope becomes big and positive. So what I see for position versus time is that I'm gaining more and more and more position each second. That's what I see with this. Now, moving over to this other one, my velocity starts off big and negative, and it becomes 0. It shrinks. It goes away. And I see that I have, in this case, a negative area, which means I have a negative displacement. So let's look at what position versus time looks like for that one. So the first thing that we're going to look at is the fact that I have a negative displacement. That means I am going to end up behind where I started after everything is done. Okay? So in this case, we are moving in reverse and stopping. So we're moving backwards and we're slowing down a little bit. Now, my velocity starts big and negative, which means the slope, because velocity is slope over here, starts off very steep and points in the negative direction. And my velocity goes to 0. So my slope has to come down to 0. It gets less steep. So if I connect those two together, this is the shape that I see for this kind of positive acceleration. I'm still accelerating positively, I'm just moving in the backwards direction. We'll look at some examples of what that actually feels like in class. All right, last case scenario. is negative acceleration. With negative acceleration, we'll look at the easiest case first. Our acceleration versus time graph is going to look like this. So the things that this says about velocity. First is that the velocity becomes more negative. My velocity is shrinking in one case or becoming more and more negative in the other case. What that tells me is that the slope of velocity the velocity versus time graph is negative. We'll put those in parentheses. Okay, so let's look at our velocity versus time graphs. We're going to do two different cases because it means two very different things. The first one will stay moving forward, but will have a negative velocity. That should be a straight line, but you can deal with it. In this case, this is what you would call deceleration, negative acceleration. You're moving forward and you're slamming on your brakes. So even though you're moving forward, your speed, your velocity is getting smaller each step along the way. That's deceleration. So for position versus time, let's look at it. In this deceleration, I still have a positive area. So I'm still moving forward. And my velocity starts big. Positive and big. And goes to 0. So, for position versus time, I'm moving in the positive direction because the area is positive. Gives me a positive delta x, so I end up in front of where I started. And my velocity, my slope, rather, over here, my slope is going to start very big and very positive, and it's going to end up close to 0. So my displacement versus time graph is going to look like that. That's all of these things happening. I'm covering less distance as time goes on. Now, looking at the other case, for the velocity versus time graph, that looks like this, where my velocity starts at 0, and becomes very negative. And in this case, I'm moving backwards. If you were in a car doing this motion, you would be at rest, in reverse, and you would slam on the gas pedal. You would speed up in the backwards direction. That's what's happening here. So, let's look at what your position versus time graph would look like for that. In this case, I have negative area. My area is under. My area for velocity versus time is under the time graph. So I'm going to end up behind where I start because I'm moving backwards the whole time. Now, my velocity starts off at 0. So the slope of position versus time has to start off at 0. And it ends up being a negative slope. So my position versus time sort of dives down and levels off like that. These are the shapes that we're going to look at. Tomorrow we'll take some time and put this in a nice graph and talk through this. And then we'll do a lab where we try to match our motion with a predetermined graph.